Okay, so today we're going to be looking at Markov chains and coin tosses and answering these two questions here. The first one, how many tosses of a fair coin, i.e. probability of heads and tails, is half. On average, does it take to get 3 consecutive heads? That's the first question. And then the second one is either 3 consecutive heads or 3 consecutive tails. We're going to answer question 1 in 2 ways. And then the second one will be Markov chains, and question 2 is far easier done with Markov chains. So let's get going. Right, now question 1, the traditional way that you would do it is you would have a look. Okay, right, on the first throw we got a 50% chance of getting a tail, and we'll have to move that up a little bit, and a 50% chance of getting a head. And if it's a tail, well, basically you've just wasted 1 go, so the expected number of goes is e plus 1. Now what happens if you got a head? Well, the second throw you got a 50% chance of getting a tail, which means you now wasted 2 goes and you're back where you started, and there's a 50% chance you got another head. And then the third one, there is a 50% chance that you get a tail, and you've now wasted 3 goes and go back to where you started, and there's a 50% chance that you get your head, and you've got your 3 consecutive heads, and voila. And then what we do is we form an equation. The expected number of goes equals this one, probability of half times e plus 1, add with a probability of a quarter times e plus 2, and then with the probability of an eighth, which is this one here, e plus 3. Okay, and well, let's multiply everything by 8 here, and then we just find out what e is. So 8e equals 4e plus 4 plus 2e plus 4 plus e plus 3 plus 3. And therefore we take away that, gives us e equals 14. So therefore the expected number of tosses of a fair coin to get 3 consecutive heads is 14. Okay, so now let's do it with the Markov chains method. So let's have a little bit of space here. So what we're going to do with Markov is we're going to have the 4 states. Okay, here's state 0, here's state 1, here's state 2, and here's state 3. So let's call that state 0, and this one here, state 1, state 2, and state 3. And this is the number of consecutive heads that you have. So state 0, you have 0 consecutive heads. State 1, you have 1 consecutive head. State 2, you have 2 consecutive heads. And state 3 obviously is the absorption state, where we have 3 consecutive heads and we are done. All right, so these 3 here are transient states because you can move in and out of them, and this one here is an absorption state because basically that's game over. And we're going to define Eij as the expected steps to get from state I to state J. And what we want to find is E03, which is the expected number of steps to get from state 0, i.e. 0 consecutive heads, which is our state at the beginning, to 3 consecutive heads. Okay, now let's draw in the probabilities. So basically, at state 0, this is at the beginning when we toss our first coin, well, we have a 50% probability that we just go straight back to state 0, i.e. that is a tail. And we have a 50% chance that we go into state 1, i.e. we have tossed a head. Now, when we're in state 1, if we toss a tail, then we have to go all the way back to the 0, so that's a 50% chance, but we have a 50% chance of going into state 2 because we've got 2 heads on the trot. Once we're in state 2, if we get a tail, we have to go all the way back to state 0 with 50% chance because we have to start again to try and get our 3 heads, and we have a 50% chance of getting to state 3 if we have our 3 heads. And we're going to use recursion now to solve for E03. So let's see if we can keep this on here. Yep, hopefully we can. Right, so E03. So basically we're starting here in state 0, and basically we take our throw, so there's the first throw, 1, add, well, what happens? Okay, well, we got a 50% chance, i.e. half, that we are still in E03 because we threw we tossed a tail, and so therefore we're exactly where we started, but we just wasted 1 go. And we got a half chance that we are now in 1-3 here. This is the half chance, i.e. we tossed a head. So that is equation number 1. Okay, so let's have a look at equation number 2. we're going from state 1 to state 3. So we're in state 1 here. Well, obviously 1 is the throw, and either what's going to happen is it's going to be a tail and we go back into state 0, so that's a half E0 3 and a half E2 3. That's if it is a head. We're going into there, and that's equation number 2. And then equation number 3, we just about got enough space on the page. E2 3, well, 1, which is our throw, or our coin toss, sorry, not our throw. Add half. Now, basically, if we had 2 heads and then we get a tail, we have to go all the way back, little snakes and ladders like, all the way back to the beginning. So that's a half E0 3, add a half, we go into state 3 here, which is E3 3. Now, just one quick word on E3 3. Well, E3 3 is the expected number of steps to get from state 3 to state 3. Well, if we've already got 3 coin tosses which were heads, then the expected number of steps is 0. So E3 3 equals 0. We're already there. So we can simplify 3. So there's the 3 equations here. Okay, so we can simplify 3 here. That basically is 0, this bit here. And all we have to do now is just solve them. So basically, let's have a look. We have here, from this one here, we have that half E0 3 equals 1, add a half, which is here, E1 3, and we're going to put in what E1 3 is here. 1 add a half E0 3, and remember it's E0 3 that we want to find, which is the number of steps to get from 0 to 3, i.e. the number of expected coin tosses. Where am I now? Add a half, so here E2 3, we have to put E2 3 in. 1 add a half E0 3, and all we have to do is tidy this up. So basically E0 3 equals 2 plus 1 plus a half E0 3 plus a half plus a quarter E0 3, and that gives us that E0 3 over 4 equals 7 over 2, i.e. E0 3, which is what we want, is equal to 14, which is the expected number of steps to get from state 0, i.e. 0 heads, or that's when we're beginning our coin toss, all the way to state 3, which is 3 heads. So it agrees. We got here, the number expected is 14, and here we've done it with Markov chains, the number expected is again 14. Okay, so now what we're going to do is we're going to do this one, which is slightly different. So that's question 2. How many tosses of a fair coin on average does it take to get either 3 consecutive heads or 3 consecutive tails? This one's much easier to do with the Markov chain. So let's have a look at our 4 states. So again, we've got S0, which is the same state, and we have 0 heads or tails. S1, which means we have a chain of 1. S2 means we have 2 consecutive, and S3 means we have all 3. And again, we're going to define EIG exactly the same as we did just now, which is the expected number of steps to get from state I to state J. So again, E3 is going to be 0 because we already have our 3 consecutive heads or tails, and we are searching for E0 3. That's what we want, which is the number of tosses to get us from state 0 to state 3. Okay, now the Markov chain looks slightly different. Basically, if we think about it, the first toss that we do, we will go from S0 to S1 with a probability of 1. We'll either get a head or a tail, and regardless of which one we get, we are 1 into the 3 consecutive heads or 3 consecutive tails that we need. So we're definitely on a run of 1, regardless. Now, when we're in S1, this will be our second throw or whatever, if we get the opposite one than we got here, well, then we remain in S1. So just to reiterate that, so let's say that we got head first and our second one was a tail. Okay, well, we're not on for 3 consecutive heads, but we are on for 3 consecutive tails because we got a tail. So we go back into S1. Oh, my apologies, sorry, I don't know what happened there. Whoops. So we go back into S1. Sorry, I have no idea what happened there. Okay, so, and basically with a 50% chance, we get the same coin toss that we got in the first toss, and we go into S2. So if we got a tail in the first one and we got a tail in the second one, we're now on a streak of 2. If we got a head on the first one and a head on the second one, we're now on a streak of 2. Okay, so that's basically what happens in S1. Now S2, if we get, so let's say we were on 2 heads, if we then get a tail, we've got a 50% chance of going back to S1, not S0, because if we got head, head, tail, we're now on the first of 3 tosses for a 3 tails. So we only go back to S1. That's the difference between this and the first question. And of course, we got a 0.5% probability that we go into S3, i.e. we got the same, whether it's head, 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 or tails, tails, tails. And there we have our Markov chain. So now all we have to do is get our equations. So now E03 basically equals 1. Well, that's our first throw. Add E13, because we are bound to be in E1. We're bound to be in state 1 after state 0. So that one's quite simple. E13. Okay, well, E13 is, here's our throw. Add, well, half the percent chance, 50% chance we go back into E1 because we have tossed a different coin to the one we tossed previously, which then becomes the first of hopefully a consecutive 3. So that becomes 1 add a half, E13, add a half, E23, i.e. it's 50% chance that we have gone into the 2 consecutive either heads or tails. Okay, so that's number 2. And E23 is equal to 1, which is our throw. Add, okay, we're E23. Either we go back into E13, so that's half E13, or we finish, which is half E33. Now, we've already said that E33 is 0. Once we're in state 3, that's it. It's an absorbing state. We're finished. Game over. We've got our 3 consecutive heads or tails. So that just equals 1 add a half E13. Now, all we have to do here is look at our equations and solve for E03. So, okay, so looking at 2 here, we have E13, half E13, is equal to 1 add a half E23. So that's basically from 2 there. And all we have to do now is put E23 in here. So we have a half E13 is equal to, where are we? Half E13 is equal to 1 add a half, 1 add a half E13. That's it, add a half E13. And so that basically gives us that E13, sorry, my bad. So half E13 is equal to 1 add a half E13. So i.e. E13 is equal to 2 add 1 add E13 over 2, i.e. E13 equals 6. So that is the number of expected throws to get from state 1 to state 3. And from this first equation here, E03, which is what we want, is simply 1 more than that. So therefore, E03 is equal to 6 plus 1, which is equal to 7. So basically, the expected number of coin tosses to get either 3 consecutive heads or 3 consecutive tails is 7. Okay, well, hope you found that useful. If you did, please press the little thumbs up button and subscribe to the Gresty Academy YouTube channel.